now I'm going to solve question 104 again, but this time using a shortcut. The shortcut I have is this. You see, notice your fxy can be expressed as a product, like say gx times hy, right? The product of each function. Your gx could be kx, doesn't matter. Your hy is a constant 1, okay? Or any other thing you want. For example, you want, well, I want gx equals like a 2kx, doesn't matter. You want your hy equals 1/2. That doesn't matter. As long as you can express in terms of the product of two separate functions here, that's okay. So now, don't come to conclusion yet, okay? That alone does not tell you, it doesn't mean that x, y are independent. You had to another condition, which a lot of people don't know. A lot of people get into trouble, okay? The second condition is your x, y had to be distributed over a rectangle area, okay? In this example here, they are distributed over a square, unit square, your x from 0 to 1, your y is from 0 to 1, okay? So that's nice, that's okay, that's special, that's kind of distribute over a rectangle. As long as you distribute over a rectangle as such, like a shape like this, okay? But this is your x, this is your y, this is a and b, this is c and d constant, right? You need to, as long as your x and y are distributed over a rectangle area, then and the joint density can be expressed as a product of two separate functions, then x, y are independent, okay? So in this case, the two conditions are met, so I know x, y are independent. So if they're independent, their covariance is 0, so the answer is B here, okay? Once again, make sure the two conditions must both be met. If, for example, if you have a shape like this, suppose this is your x, this is your y, suppose this is your shape like a circle here, okay? If you're shaped like a circle like this, and if your x, y are distributed in this circle, not a rectangle, even though your product density could be, like say, fxy is the, okay, is a, say, constant like say, k, that does not mean you cannot come to conclusion and x, y are independent. Just make sure, I want to emphasize that two conditions must both be met. That one condition is you can express the joint density as a product of two separate density, one for x, one for y. And the second condition, which most people forget, is that the distribution area had to be a rectangle area. If these two conditions are met, you're safe to say that the two variables are independent. And that's the end of question 104.